Thank you, everybody. Thank you so much for joining us today. Welcome to Mitigating Biased Algorithm in the Real World. We have a speaker, Hinda Han. Um, Hinda Han is an endowed professor of data science at the University of Amsterdam, where she's scientific co-director of the Civic Lab, AI Lab. Her research focuses on developing solutions for best practices for safe and responsible data science. Hinda obtained her PhD in applied statistics from the University of Lyon, France in 2010. Some of her most recent work revolves around explaining why a model works, why a model makes error in forecasting tasks, and investigating whether explaining these errors increases user trust. So I welcome again you, Hinda. Thank you so much for taking out your time. And we will start off. I will hand over to you. I will be there in the chat. If you guys have any question, please put that in the chat, and Hinda will be answering them at the last 10 minutes. So over to you,
Sounds
Hinda.
great.
All the best.
Thank you so much. Thanks for joining the session. I'm excited to talk about my research topic around mitigating algorithmic bias in the real world. So I want to start by giving a short introduction about my lab at the University of Amsterdam. So we are called the Civic Al Lab, and we're essentially focused on trying to make AI applications, AI systems more inclusive, but also more useful for the citizens of the cities around the Netherlands. So we're funded by public organizations, but we also have a lot of outreach programs towards other countries. And I encourage you to look for us online and to also follow our LinkedIn or Twitter pages where you can read more about the research that we do. So the talk that I'm giving today is related to the research that I'm doing at the university, but I'm also, so as a moderator introduced me, she said that I'm an endowed professor of data science at the University of Amsterdam, so that's the research that I do, but the rest of the time I'm a data scientist and I have my own consultancy company where I essentially have clients that have data science related questions, and a lot of the questions that they have is around bias and how do we make sure that the systems that we're developing are not biased or are going to end up discriminating folks and have unintended consequences. Algorithmic fairness is always how I like to start my talk. So why should we care about it? Why should we want to make sure that the system we're developing are fair? One compelling argument I would say is that we see a lot of bad applications of AI or bad applications of systems that are going to harm communities. In the Netherlands, we had a lot of stories in the media in the past few weeks where public organizations have used AI-driven systems that ended up discriminating against minorities or people in the country that were accessing things like welfare allocations when they have kids, or there was also some scandal in the past few weeks about the immigration body in the country that's regulating how people apply for visas and such. That was also used in a system that was using ethnicity and citizenship, for example, was just something that we cannot do in the Netherlands. So all these applications are raising a lot of concerns among citizens, among policymakers, among scientists. And so I think that the AI community has realized in the past few years that this is a very important topic, and there has been a lot of contributions to kind of try and mitigate some of the things that we see happening. And I'm going to dive into that a bit further later in my talk. Another reason why we should really pay attention to what's happening in the AI landscape and in how companies and institutions are using AI systems is compliance. In Europe, in many countries in Europe, there is this GDPR law that you probably heard about if you work in computer science, where we're essentially told that we cannot use automated systems to make decisions about people without having any intervention from a human, but also we're not allowed to do things like profiling based on gender or other sensitive attributes, what we would call sensitive attributes, so things that shouldn't belong into a statistical model. So this is one of the other reasons that we should really pay attention to how we are building our systems. And so GDPR also has fines in place if companies or institutions are not actually complying. And if you look this up on the Wikipedia page of GDPR, you see the latest fines that were given to companies, and they can be quite high. So this is also a compelling argument, in my opinion, to try and pay more attention to these kind of problems. And of course, naturally, when we have these automated systems that use data and generate these outcomes that affect us in our daily lives, they are going to raise they're going to raise concerns and raise questions. So, for example, when we're shopping online, we might, try and understand, why am I seeing this ad? Or on a social media platform, why am I seeing these things recommended to me? Or why did I get this discount? Or why did I not get this discount? Well, I know that my friend who's also shopping on this website did get it. Why am I getting all these recommendations? But also maybe more critical applications in banking, for example, when you're being rejected, when you apply for a loan, for example, when more and more banks are using now automated systems to make this decision. So we are also finding ourselves in situations where we wonder, why is this happening? And we want explanations. And we also want to figure out whether we can change the outcome of the decision. And often, well, at least we're used to in the past, having a conversation maybe with a I don't know, an official from some public organization that would explain why our request was rejected. But when you have these AI systems being automating these tasks, we can't really get a clear answer as to why we have been assigned a particular outcome. So I want to give at this stage a bit more of context, and I'm going to give some definitions that I'm going to use in the remainder of this talk. So I've talked about bias and discrimination earlier. So in this talk, and way I think about bias is this systematic errors that happen that are actually unfair outcomes. And the reason why these unfair outcomes happen is because of the way the algorithms, the models have been designed. It could also be due to how the data has been collected and all the modeling choices that data scientists, for example, make. And these algorithms, these models essentially learn these bias and perpetuate it. And they perpetuate it at scale because, as we know, algorithms are cheap and they can be automated and affect more and more people. And in this context, I've also been talking about fairness. And so fairness in this context is wanting for outcomes of any models to be assigned fairly to different individuals. So we're actually going to analyze and try and understand how these outcomes are going to be attributed to different people based on their ethnicity, for example, or their gender. And the core principle of wanting an AI system to be fair is that we want to avoid bias. So we want to avoid these errors, even if they are supported by the data. So even if the data tells you that this is how this outcome should be assigned to a particular individual, it doesn't mean that we should trust it, because we need to remind ourselves that models are being put together and developed by humans, and humans have biases, and so does the data. And it's, I think, useful to think about fairness as a political construct, because it would really depend on the person, it would depend on the company, it would depend on the background of and then the context of a project, on whether or not we care about generating fair outcomes. Sometimes it's just not relevant given the application, and sometimes it's crucial to have fair outcomes. And when we don't have fairness, and when we actually have models and algorithms that make errors, we have what we call harms. So we are going to harm communities, we're going to harm individuals. And I find it useful to divide these in different types of harms. So this isn't an exhaustive list. There are a lot of other things that can happen. But this is just a useful way of categorizing these things and to also further the conversation around them. So harm of allocation, harm of representation, and what has been called reduced quality of service are typically some of the things that we see also being reported on by the media, for example, and you might have seen some of this in the past. So harm of allocation is mainly an economically oriented view of the consequences of an automated system that's driven by AI. So it's typically when you don't get a job interview because the AI has deemed your CV not worthy, for example. So that's a harm of allocation. You're not going to be allocated a resource or a benefit. Harm of representation is when we have an underrepresentation of a certain group, for example, in our training data or in the data that we are using to develop our models and our algorithms. And that ends up it ends up in a situation where we have a system that is going to generalize to groups that it hasn't seen in the data, and that essentially creates problems. I'm going to give a couple of examples on this. And reduced quality of service is still something that I find very important, even if it's not very critical in everyday life, but is essentially when the system is going to produce degraded user customer experience. Based on personal characteristics, for example, stereotyping and denigration. So you can think of those cameras that have been developed by a brand in the past years where it actually couldn't detect certain types of faces or certain types of skin colors. This is typically reduced quality of service. So it's not something that's going to impact your life dramatically, but it's still a degraded experience as a user. So I want to give some examples of the type of biases that we think about when we trying to discuss these problems around discrimination of AI systems. And historical bias is something that we often encounter. And I like to use this example where we look at the divide in the gender gaps in different industries. And this is really relates to an example. I don't know if you noticed in the earlier slides, there was a headline about Amazon sexist recruitment tool, where essentially the company has divided a tool that would help them rank their CVs and to select candidates, and it ended up being disadvantageous towards women's CVs because essentially it didn't see enough of those. So it was just discriminating against very bright women candidates. So why does this happen? It happens because we know there's been a historical bias towards women being underrepresented in tech jobs, which means that we can learn less about what makes a good candidate in this type of applications, which makes it very hard for a model to learn that and ends up, perpetuating bias against women. So even if the model is just essentially picking up patterns from the data, that doesn't mean it's right. It doesn't mean we should be doing it. And I'm happy to discuss later on if we should be using these type of systems when it comes to recruitment. I mentioned earlier something about harm of representation, and this is a very nice example. I thought this has been fixed or somehow, challenged in the past few years, but it hasn't. And what I did is that I Googled on Google image nurse, and what I've seen is, mainly you see women nurses appearing. You can do the same experiment with the words personal assistant. You will see a lot of female personal assistants. You won't see men doing that job. And that actually tells you a bit about how biased the data is about this type of jobs. Another interesting example, and maybe this will resonate with the folks that are joining us from the UK, is a measurement bias, which is when we are going to use certain features, certain variables in our model that we think are going to measure something, but it ends up measuring something else. And this is an example from the high school exams in the UK that had to happen in 2020. So during the pandemic, the students at the time couldn't sit on their exams because of the pandemic, obviously. And there was an initiative where they would actually be assigned grades based on past history, past performance of the schools, instead of having them sit on their final exam. And what this ended up doing is having very bright students that came from actually schools that were in poorer neighborhoods that ended up being rejected or having lower grades lower grades than expected, because they use essentially these variables that were not measuring success or historical performance of the students, but they were measuring things like class size and the diversity or the distribution of the grades within those schools. So instead of actually measuring how performant the school is, how performant the student would be, we ended up measuring how rich the school was. And this is what we typically call measurement bias. So we know that these things happen. They've been documented. A lot of people have been working on this. So now, obviously, a natural question would be, okay, what do we do about that? How can we avoid bias? And this is where I'm going to ask you to go to the Slido website and answer the question that's there. So I'm going to stop sharing my screen to go to Slido, and hopefully we can do that.
So you can click on Slido. It's just basically beside chat people in Slido. So we have an option Slido. So you can just answer these questions from here on Hopin only. If you face any problem, do let us know. We can share the website link as well. But I think Slido is in there with the chat, so you can answer there.
So I'm going to stop sharing my slides to go to the Slido website and see what the answers are. Okay. There we go. So I'm still seeing people voting. Better data has 71%, better algorithms. Okay, that's interesting. Great. Well, thanks for, I'll go back to this one later as more folks would have had a chance to vote, but very interesting. All right, let me share my slides again. Okay, great. So essentially, most of you think that we should either, go for better data or better algorithms and models. And interestingly, I don't think anyone has selected don't build the AI in the first place, which I think is an interesting topic we can maybe discuss at the end of my presentation. All right, thanks, guys. Sorry, I think I missed one slide. So how do we avoid bias? I think there are a lot of initiatives, a lot of work that's been going on in the space, and I'm just going to mention some of the things that I find interesting and helpful as a data scientist to try and answer these type of challenges. So ethics is obviously a very important aspect we need to think about, and there are a lot of ethicists, philosophers that think about these AI issues and come up with some solutions and things that I think some of us will find more or less practical. I do encourage you to take a look at this ethics guidelines from this committee from the European Union. I find it interesting. I'd love to hear some ideas or thoughts later on when we get to the Q&A. If you've read this, what do you think about it? Is this helpful? We obviously have a very active, what is called the FACT AI community. So FACT stands for fairness, accountability, confidentiality, and transparency. So FACT AI, the actual conference that's called FACT, is a great place to find a lot of free resources, tutorials about these topics. There are a lot of other conferences as well, so I also encourage you to look that up. And now I'm coming to the part that is actually the core of my talk, which is mitigation algorithms. So this is one way I would say the AI community has put forward to try and mitigate and solve these issues of bias. So there are a lot of things available, and you can essentially divide them into 3 groups. So you either modify your data ahead of developing your model, you either change your algorithm itself, so how it learns in order to generate a desired fair outcome, or you actually post-process your model once it's trained and developed. Then you look at the distribution of the different outcomes, you look at the groups differences if you have a divide in the population that's actually being assigned to different outcomes, and then you try and kind of rectify that. And there has been a lot of attention on these mitigation algorithms. And in my career so far, I've seen a lot of people, a lot of scholars saying, hey, we can fix this through changing the data, fixing the data, or fixing, the way you learn, the different algorithms learn. So I think you've seen where I'm going with this. But in my opinion, we need to have a wider conversation about how to fix bias, because bias doesn't come just from data. It comes from the way data is collected. It also comes from how we actually think about modeling the system that we're trying to improve or automate. But I'll go back to this in a bit. So a bit more about mitigation algorithms. You can read more about them, and there are a lot of free resources. One of them is this tool. It's called AI 360, AI Fairness 360, I think. And it's a platform where you have a lot of Python packages that have been kind of put together that do all sorts of debiasing. It's very interesting because even if you don't code in Python, if you don't know how to do that, you can still use the user interface. It's very friendly, in my opinion, and you can test some of these mitigation algorithms and see what they mean, how they work, and get a feel of what the results will look like. So it's important to know that when you use this type of mitigation algorithms, they're supposed to kind of fix the bias in your models. There are a number of assumptions that, in my opinion, are not always very realistic, but in some cases they actually, can apply, and it could be super useful. So the first one is that you have to have a known sensitive attribute. So I should have maybe mentioned this earlier, but when we talk about bias and discrimination in AI, we typically have a sensitive attribute, and we're going to look at the behavior of the model with respect to that attribute. So it could be, for example, when I talked earlier about this recruitment algorithm, so the sensitive attribute was gender. So how is the model behaving towards men and women, for example? You also have, you need to have a defined fairness objective. So you have to know in advance what you expect from your model. So typically you want maybe 50% of rejection rates, or some other percentage or statistic that you are sure of, and then you think, hey, this is what I'm aiming for in my model. And then you'll have to tweak it accordingly. So these type of debiasing algorithms, so I've checked this out, I think, a few weeks back, and I feel like it's mainly focused on supervised learning tasks and binary classification problems. So essentially, we want to predict whether which label you're going to have. And in my experience as a data scientist, a lot of the work that I do for companies, there's a lot of regression involved. I don't know if you agree with that, but I'd love to hear experiences, which means that a lot of this of these contributions just simply don't apply to the tasks that I have in practice. All right, so how do we go from here? You have these mitigation algorithms, and you have this context where you're going to try and, I would say, do your best as a data scientist to not have a biased algorithm. So what does this look like in practice? And this is kind of an advice that I've read a lot about, and this is essentially what people should say you should do is you should test your model. This is a great idea, and I think we should all just test models, but you should test it for bias and lack of fairness. I essentially want to make the point here is that it's not always straightforward to include that into your development cycle. Sometimes it's just out of scope to think about fairness because the person who has required you to develop this model or this system just doesn't care about fairness, or it's not something that is aligned with the business objectives, which makes it incredibly hard when you're a data scientist or developer to say, hey, I'm not going to deliver on time because I need to do more testing to check things like data sets and balances. I'm going to check that my model treats different groups fairly. I'm going to try and understand my model behavior and monitor the predictions. I know that these last two are incredibly hard because a lot of companies that are not necessarily very advanced in terms of data analytics, they just want to have this proof of concept, and they just want to show, to the business that they can leverage data and data analytics, which means that they're not necessarily going to be favorable, or they're not going to support investing more time and effort in monitoring the behavior of the model. And this means that as a data scientist, you sometimes have less agency, compared to what the AI community expects you to have, and gives you all this advice about how you can debias and monitor and check these imbalances. Sometimes it's just not doable. And I think that a lot of folks need to understand that before, offering us more algorithms that are going to help us debias. So essentially, this slide was just to give you, the same speech, but then in 2 bullet points, so I can skip it. And I want to give you an example. This is something that I've encountered a few years back, and it's a similar. So it's not exactly the case I had to work on, but it's something very similar. So a common setting where these questions of bias and fairness become really challenging is you have a company that wants to automate a tedious or repetitive task. They acquire or decide to co-design an AI system with an external vendor, or maybe with the internal data science team, and build some pilots around that. And because of, or thanks to the media, we have a lot of information about, how AI can help improve some business processes, and more business leaders wants to invest in AI and want to do more things with automation. So typically you have this question of, hey, we're not going to, or we've purchased this tool. Can you make sure that we can use it in an efficient way in the company? So let's look at this example where a company acquires a succession planning tool. So if you're not familiar with this, term, succession planning is essentially around the time where companies do this performance review of their associates, they also do succession planning, which means for some of the positions that are open, they're going to consider candidates internally, and essentially it's like how you get promoted. And in some of the companies I worked for, we would be assigned a score to say, hey, this person could be qualified to go to the next step of their career. So if you are an analyst, you could become senior analyst, or if you're a senior analyst, you could become a manager. And this is done manually in this example. And what the company is trying to do is to automate that process and make it faster, but also make it more fair, because this is also something that a lot of business leaders are exposed to, that AI is fairer than humans. So in this example, the model that is being used is a regressor that's trained on historical data on performance of the different associates. And each associate will get a positive recommendation score, and based on that, you will be considered for a promotion or for a the next level of your career. So some of the metrics that are used are performance, education, tenure, and some of them are just factual, I would say, and others, performance reviews could also have some bias around that, of course, because it's quite subjective. And what I would call the practitioner's task, in this case is a data scientist, is to evaluate the tool and approve the use by the HR team. So this is kind of the context of our example. So to me, this is what this situation looks like. You have the practitioner in the middle. It could be computer scientist, data analyst, who has the ability to look at this tool, to test it, and then give some reports to the business leaders. On the one side, you have the business that wants to automate the task. On the other side, you have a vendor or someone who's external to the company who is giving you the tool for testing. Some of the things that we need to keep in mind when we require people to do this type of evaluation is that we often have regulatory constraints about what we can and cannot use. So the, sorry, I'm having a pop-up on my screen. I'm going to get rid of it. There you go. Sorry about that. So we often have regulatory constraints. For example, the vendor has been able to use some features to develop the tool. That doesn't mean that the practitioner is able to do the same, right? It could be that that person cannot actually rebuild the model from scratch, for example, to have a baseline. They also have a limited agency in terms of modifying the tool. So if you do find out that something is off, you're not necessarily able to tell the vendor, hey, you need to fix this, because it's just out of scope for the evaluation process. And you are being asked in the situation to mitigate the bias or the potential bias. I'm not saying this is necessarily bias, but even if you do find something's wrong, you're actually being asked to do this after the fact. And I think that this is one of the most common problems and challenges in a company setting, is that you have you essentially have to come after the fact. Oops, I think I am going in the wrong. So what I'm advocating for, I think during my talk, but also in general, is that we need to have a culture shift. So in a lot of these companies that are trying to use more and more data science tools, is that we need to go from how can we make the system fair in deployment, so how can you make it fair after it's been developed, to how do we establish standard operating procedures in our business to ensure fairness throughout the development process. So instead of just asking people to fix something that's already been developed, you're actually going to include the competent folks in the company to be involved in the design process from the start. That way, you don't actually have to have a situation where you have very little agency. All right. Now, just checking the time. I think I'm doing okay. Something that really helped me when I have to deal with this type of situations is ask a lot of questions. And some questions are almost trivial, but I'm always surprised that I don't always get a straight answer to them. For example, why do we need AI for this task? Apart from having to automate this, is it worth it from a business perspective to spend this much time and money in validating a software that we're not even sure we can use, than to actually maybe automate some of the ways the HR folks are working on this project? Do we know if the system is transparent? Do we actually understand how it works? My question is, what are the potential harms that could occur? So think about these questions ahead of developing and purchasing a tool like this. And also, I think this is an important one. I'm not going to go through all the questions, but I'll be happy to share my slides later on, is who is responsible for ensuring fairness? Is it really just a data scientist that needs to have that responsibility, or should be a collection of people that actually have different types of roles in trying to decide on this topic? Something that there are three things that I think is going to help us do things better when it comes to organizational fairness, or doing things better in terms of automating tasks and trying to think more more efficiently about fairness and avoiding bias. So one is Roise Awareness. So one thing that I use routinely is this small, I call it the fairness card. It's just one page of questions that I divided in three different topics. So you have questions about agency, about privacy, and roles and responsibilities. And these questions are incredibly helpful in starting the conversation with business leaders that are worried about purchasing the system, or if they've already done that and then they want your opinion about it. As I said, just ask simple questions can really help start the conversation and actually pinpoint, the risks and how and start the conversation about how we could solve them. In the example I'm discussing here, we have this practitioner, because it's been my experience so far, is you have just one person designated in the company that we go to for these type of questions. And what I think would actually help is to have more than one person, obviously, and think about these debiasing or this fairness evaluation as a collective effort. And you need to hire more talent. You need to invest in people that are going to be able to answer these questions. And they don't all have to come from, data science or computer science background. I think that having folks that are specialized in design and user interface and those kind of things are also helpful. But also business domain experts that are going to be able to answer these questions, and have a collection, a group of people looking at different aspects of the issue and trying to answer it. And this is something that often companies have a hard time hearing, because they just want a quick solution, a quick fix. It just tell me yes or no, can I use it? And I just try to explain to them that it's more complicated than that, and it should be an interdisciplinary effort to get there. So what actually helps a lot in having these conversations and trying to find solutions is to invest in stakeholder education. I know that a lot of young data scientists and that have just graduated and just excited to join a company, join a project, and do very cool stuff and program things and see that their work has impact. They don't necessarily see stakeholder education as something very exciting. I guess the point I'm making here is it's actually worth investing, because this is what's going to make your life easier on the long run. Like, if people understand what you're working on, if they understand how data is being collected, the data is actually just someone at some point just entered that data in a system. It's not things that we just collect magically, and understand the different biases and issues that could occur. If you really actually invest in that education, it will definitely help you have the right sort of conversations and get you more agency in making decisions about these important questions. And this is there is a link. I'm not sure if you can see it at the bottom of the slide. This is a great website that I think it's called Data Responsibly, and they have great comics about AI, bias, etc. And I think they're very well made and they're very exciting. So this is something that I would typically use to educate senior leaders, because it doesn't always have to be a boring lecture about what is AI, and we need to be ethical and those kind of things that don't give you any concrete steps, don't give you anything concrete to work on. But doing things a bit more in a more creative way definitely helps with stakeholder management when it comes to debiasing or trying to debias algorithms. So that's it for my talk today. Thank you so much for joining the session. I think we're going to open up the chat for questions if there aren't already questions there. Thanks a lot.
Thank you so much, Hinda. It was so great, and trust me, it was very informative. And we have a bunch of questions for you. So let me ask in the very beginning. All right. So, Anne Kilzer, if I'm sorry if I'm pronouncing your name incorrectly, how do we get other people beside folks who come to this type of session to care? Example, you shared a headline, Amazon refuses to stop selling biased AI. Right? Is regulation a good strategy to mitigate harmful AI biases?
I didn't hear the last part. I'm sorry.
Oh,
okay. Okay. I think I got it.
Cool.
Is regulation a good strategy? I think the regulation definitely helps, and I think it's essential to have regulation as well. What I would like to see is more AI scientists that actually understand more about data and the data science world be involved in these discussions around regulation, because what I also see happening is sometimes the folks that are making the laws are not necessarily domain experts. They of course consult with domain experts, but we also need to be more involved and understand more and call for more regulation. I think that was definitely super helpful in trying to make things better.
Thank you so much. So our next question is from Anna Marie. When search results are biased, but reality is also unbalanced, such as for the example of images of nurses, would we want search results to reflect current proportions or the proportion of an ideal future? That's a great question.
That's an excellent question. Yeah, absolutely. Yeah, I think the pictures that I was showing to show that type of bias, this is almost cliche, it's just to show you what could happen. But indeed, I agree that, I think that we should see, I think that's a great way to see how biased we are. And I think, I don't expect Google to start and fix the algorithm to show us more, other genders when it comes to nurses or, but I agree that, I would like the research results to reflect current proportions indeed, and then to see like how far we need to go. But you can also think of this in there are other applications where you would want equal representation. For example, when you have image detection and try to recognize faces, for example, these type of tools, they don't work equally well on different types of skin shades, and this is something that we want to fix, right?
Right. Thank you so much. That was an excellent question. Cindy Lee is asking, it seems there is a lot of emotional intelligence involved. How do you build a team that can answer these questions fairly?
Yeah, it's an excellent question. I think that, So one of the possible answers I had in my Slido was, should we not build the AI? And I think that this should be a possibility. We should put this on the table. Like, are we ever going to get to a point where we can actually model what a performance is, or what a good candidate is ever going to be? Do we understand enough about human nature that we can capture through data and then put in a tool that's going to give us a faithful result? I don't think so. My personal opinion is that we shouldn't be. Some applications, I think you should just automate, make the work more efficient, but you don't have to leave that to an AI. And for those who say, AI is less biased, well, you need to think about, who is going to build an AI? It's going to be human. AI doesn't build itself, at least not yet. So I agree that I think involving people that, like professional coaches and psychologists and people who understand everything about, cognitive psychology and, organizational psychology are maybe more, qualified to make those decisions than a bunch of features that describe your best performance.
Right. Thank you so much for answering that. Our next question is from Daria. In case of bias appearing due to a data shift, what can help to detect and reflect on it?
I think that that's a hard one, because I always try to think about these problems from a very practical perspective. Like, you might have data shift essentially when you have a model in deployment, but then that the new data that's going to come in is not going to look like the data that you've had in the training set. There are some, let's say, technical solutions to that, but I think it's very difficult because you're still going to make a lot of assumptions. So to me, what would really help is to think, when you think about deployment, you should also think about monitoring and have some way of figuring out how the model is performing when it's in deployment, and get that feedback, and to still be involved, in your model development when you get that feedback, and then reflect back and think, hey, should we have done or build this component the way we did? But that's what I think is incredibly hard to do it, because often the folks that develop the model are not the ones that are going to deploy it, or the ones that are going to kind of get feedback from it. And as I said, sometimes the different business metrics that you have, the KPIs that you have about, how many people have clicked on something, and those kind of things, like, they don't align with your perspective, with the fairness that you're trying to achieve with your model. So it's very difficult to align the two. So I don't have an easy answer to that. I'm sorry, Daria.
Yeah, that was a difficult question to answer. All right, so I think we have a question on Slido. Can you check if there's any question on Slido? Because that is it in the chat. If you guys have any questions for Hinda, please put it in the chat and we can answer it right now.
Yeah, I don't see anything on Slido.
Cool.
But all right, I think we can maybe take a couple more questions. So Lisa's saying, even when AI can build itself, it's still being built by something built by humans. Yes, absolutely. Thank you, Lisa. I agree. All right. Yeah, if there are no more questions, maybe we can.
A last question from Anna.
There you go. There's a
Yeah.
new one.
Can you share the name of the
Yes.
content? Yeah.
Yeah, I put it in the chat. It's called FACT. So fairness, accountability, transparency. I definitely encourage you to also look at some of the tutorials from over several years, and they are freely available. You can watch the videos, you can access the talks. It's really great. Especially those of you who are, if you are PhD students and you're interested in that, there's I would say material around that. Yes, and the citation, yes. You know what? Well, maybe we can collect more questions where I look for it, but I think it was called, there you go. Thanks so much. Data Responsibly, exactly. That's called Data Responsibly, GitHub Comics. It's a great website. Let me check again the life polls. Yeah, I think there is 3% now that says don't build AI. So I'm happy that that number got up. Really good.
Okay, then. So I think that is it from. Oh, we have another question. Thank you, Cindy. Can you share your personal journey as you reflect upon these questions? That's a great question.
Yeah. So, Cindy, do you mean the question around emotional intelligence, or do you mean in general? I'm going to assume a little bit of both. Okay, great, thank you. Okay, so Cindy is asking about my journey to AI fairness. I think it's been it's been really tough, I think, because I felt often that I was the one in the room advocating for not doing things because I was worried, or because I knew we didn't have the data or the resources, or in terms of people, in terms of platform and and infrastructure to do the monitoring, the reflection on the behavior of the model, and then people wanted quick wins, and then I would often be labeled as the person who didn't understand business. And that is a label that you don't want to have when you are a data scientist in a company. So I found that very complicated. But somehow I would say I persisted, and it's just something that matters to me. I think that I mentioned this at the beginning of my talk, but we see more and more public institutions using AI, and that means that now people that are often in the margins of our society are going to be the ones being harmed by these systems when they make mistakes, and they don't have anyone, I would say, in front of them, like any public servant or someone they can go to complain, because the AI did it, so it must be right. And we're not thinking about this possibility of recourse, that we don't agree with an outcome, we want to appeal it, right? And the people that have been marginalized are going to be marginalized even more. So I feel like someone has to stand up for this. And I also see that the students that I'm supervising or at the university, they also care about these topics a lot. So I don't feel like I'm alone, but I do feel like in I would say a company, corporate business type of environment, people have a different timeline, and you are going to be needing to fight a bit more. So that's why I try to invest in educating people and going really slower than I would like to. Obviously, like I'm a data scientist, I want to code, I want to build things, but I also know essentially you have to invest in education and also accept failure. Sometimes people won't care, and they will create an awful system that's going to do awful things, and just part of the way the world works, I guess. And you need to accept that as a part of the job, I guess.
We're getting more questions on that. So which university are you based at? You can answer that. And also, and do you know any network for lecturers, senior lecturers who work in data and ethical AI?
There are a lot of them, I would say. So maybe what I can do is share. I'm not sure how best to do that, but I maybe on the Slack. I don't know if everyone is there, but I can share some links towards those type of communities. I think if I remember that correctly, on the FACT conference website, there's also like related links or related conferences, and there you have a lot of things around communities that are going to essentially be busy with the same topics, and maybe there's interesting information. There's a question you mentioned earlier that maybe sometimes AI is not the answer. Can you talk more about your opinion on that? Yes, I think I've kind of stated that earlier just now when I said, like, I'm often the person in the room that says AI is not the answer. Typically, the folks that are pushing for an AI system or machine learning, they don't really understand that before you get to a model that's going to be useful, you need to understand what type of data you have, and we need to understand if your data is actually capturing the system that you're trying to model or automate or improve. and sometimes it's not worth it building a sophisticated tool that's going to require a lot of computing time, and you're going to have to buy servers and so on, and have qualified people to maintain that model. Sometimes it's just about looking at the Excel files that people are using, for example, in HR department, and build them a tool that's going to be more friendly for them, and they can just do their job more easily and faster, and that would actually solve the business question that we had. You don't have to necessarily model everything and have something more intelligent in place, because there's no guarantee that it's going to actually be performing better. And I think it's also you have to keep in mind that when people talk about AI, they just mean data, in my opinion. Like in a lot of situations, I figure that people don't actually, when they say AI, they don't mean, machine learning. I'm going to be customer facing and delivering, the outcomes through an API. That's not what they mean. They mean, I want to use data because I want to make decisions that are supported by facts. And I think once you understand that, and once you kind of frame or position your opinion on this, and with that in mind, I think it makes the conversation much easier. Sometimes people will want to have machine learning written down on something that's not machine learning, and just because it's part of a business objective, for example, in this year we have to develop machine learning. I've had that experience recently, and I'm like, okay, sure, we can call this machine learning, and then you just have a whole slide that says why this is not machine learning. So as you have to still be comfortable with calling things machine learning when they're not, but as long as you document that properly, I think you can get away with that.
Awesome. Thank you so much, Hinda. And that is with our time. Thank you, everybody, for joining in today. And I hope you guys enjoyed it and find it as informative as I did. Thank you so much. And please head over to our expo and networking sessions. And we would love to meet you there. Thank you so much, everybody. Bye, Hinda.
Thanks,
Bye,
everyone. Take care. Bye.